Okay, hi everyone. This is the second episode of Mr. Soon's CP thing. Alright, we're going through exercise 6 today. Exercise 6 is about lists. Alright, lists, as you know, lists are stuff that you can enter sequentially. Alright, this is a list. Alright, you can access parts of a list. You can access last elements of a list, a lot like strings. Alright, strings. Strings are... In some languages, strings are actually arrays. Alright, array is another name for list. Alright, R equals to 1, 2, 3, 4, potato. Alright, and you know that you can store different things in things in Python lists. Alright, different types of things, and you can do stuff. You can loop through your lists. Alright, let me loop through a list and show you. Loop, loop, loop. Alright, I did this at the start of the string episode. I'm going to do this for lists. Alright, we can do for I in range length of an array. Alright, I actually haven't defined an array, so I'll do that here. Cows, potatoes, bananas. Alright, so if I do this, alright, I can print array bracket I. Alright, ignore the sound effect coming from my computer. Okay, alright, if I run this, yes, I want to save cow. Alright, and I get cows, potatoes, and bananas. Alright, so far so good. Okay, next, alright, we can also iterate through the items. Alright, for item in R, I can also print item. Alright, and you see you get cows, potatoes, bananas as well. This is from the second iteration. Alright, some of you have asked, what's with this I and item? Are they special? You know, do they have any special meaning? No, they don't. Okay, these items, alright, these are just index names. Alright, what you are effectively saying when you do this is you're saying, alright, first round I equals to 0, alright, and then print ARR bracket 0. Alright, second round I equals to 1, alright, then it'll check to see is I still within the limit. Alright, because the limit is defined by range length of array. Alright, let's break that down. Length of array in this case is 3. Alright, range 3 will give you actually give you a list, alright, 0, 1, 2. Alright, so what you're doing is first round is taking the first element from 0. Alright, 1, 2 is taking this one. Alright, this element. Second time round, okay, you are actually getting 0, 1, 2, but it's actually going to get this one. Alright, so I equals to 1, alright, and then it prints ARR 1. Alright, so that's what looping is doing. In case some of you are still a little bit confused, alright, you think this is some kind of magic, you know, it's best if you can try and remember it, alright, but it's also good if you can try and understand it. Alright. Delete. Okay, then there's also this syntax for item in ARR. This is called, it's called iterating through the items. Alright, so that means the first round, it will take the first item in ARR, and you set item equals to ARR 0. Alright, then you say print item. Second round, it will take the second item, ARR 1. Alright, and then you print item. Okay, and this goes on and on and on until you run out of items, alright, in which case that's it lah, you can't do anything else. Alright, so this is just a very, very basic introduction to looping lists, alright, which some of you are still a little bit confused by, alright. I'm just moving this stuff around the screen. Ooh. Okay, sorry. Alright, so let's go back to this, right, list processing, the exercise. Right, so the first question is to write functions for each of the Python operations and test your algorithm by writing out a suitable function, okay. I didn't actually ask you, well, you might not have done this, but I didn't. Okay, so the first one is to say, you know, normally there's a built-in function, alright. Built-in functions, alright, which act on certain operators, alright, it's ARR, have a dot notation. So ARR count cows, alright. So you can see in my tooltip over here that popped up briefly, alright, it counts the number of times cows occurs. Okay, very simple, right? So what I'm going to do now is you are going to be entertained by my voice while I open up my solutions. Solution 6. Okay, 6-1. Alright, so what this does is, so all these exercises are to get you used to iterating through lists. You are going to be doing this like non-stop from now till who knows when. Alright, in your latest exercise, your dictionary problem set, you've done a lot of iterating. Alright, in the latest exercise, the one about file processing, you are iterating through parts of the file. So we make computers do a lot iterating. We are lazy people. We like sitting around and letting computers count for us. Okay, so let the computer do the dirty work for you. All right, this is not how you would think, right? This is not how you wouldn't say, oh, I'm presented with a list of numbers, and I'm going to check through every single one of them, and use my fingers to count the number of times 4 occurs. Oh, 1, oh, 2, oh, 3. Okay, no, you will just glance at the list and then you mentally add it up. But no, that's not how the computer works. Computer does things sequentially, alright? So you're going to be doing a lot of iterating. Alright, so this is a counter that I've written. It's your accumulator pattern, counter equals to 0. For every item, if the item is equals to what I'm looking for, alright, I will increment the counter. Alright, another syntax for this is counter plus equals to 1. Alright, and what I've done here is some bit of testing just to, I pass in an array, I pass in a list, sorry, and I count the number of times 4 happens. Alright, so as you can imagine, if I run this, I should get 3. Okay, simple. Let's do the next question. Oops, I don't have the answer for that. Alright, let's write it. Let's do this live. Whee. Okay, is in. Alright, is in. So this is if X in my list. So you've seen the in notation. Alright, let me just bring back this thing over here. You've seen the in notation over here for item in array. Alright, this means that you look through and you will assign it to it. There's also another notation which is if cows in array, print yes, cows is in array. Alright, my grammar is terrible. Alright, this one just checks to see if this element is inside this array. Alright, so I will run this and you'll say yes, cows is in array. Alright, potato. Alright, then you say yes, potato is in array. However, this will not print anything because potato is not in array. Okay, so far so good. Let's carry on. Okay, so this is my exercise. Sorry, so I'm going to do a manual one. Is in my list. Alright, so I'm going to say def is in. Alright, my list, comma X. Alright, and I'm going to check through every single item in the list to see if X is in there. Alright, so you can imagine for item in my list. Alright, check through every single item. If item equals to X, alright, and then it will return a boolean. Alright, that means that if it's true, it will return true. If it's false, it will return false. Alright, this part is a little bit counterintuitive, I guess. Well, I guess it's just not something that you expect. Here's the condition. Alright, if item double equals to X, I can return true immediately. Alright. Otherwise, I shouldn't do anything. Don't do anything. Alright. Okay, can you imagine? Okay, so let me bring up a test for you. Okay, so let's say list equals, oops, I can't use that. List equals to 1, 2, 3, 4, 5, 6, 2. Ignore the ball, there's my cat playing. Then I'm going to say if, alright, I'm going to say print, let's say condition equals to is in list 1. Alright, so condition is true if the moment, alright, as long as list lis has the number 1. Alright, so what happens is that as a computer, I'm going to look through this. I'm going to say 1, 2, 3, but actually no, once I hit 1, it's true already. Alright, condition can be true. Okay, so I can immediately return true. The moment I look through, in fact, I don't even need to look through the entire thing, right? I just look through, I realize, oh, I found it. Alright, I can return true. Alright, this is an important principle that will come in handy when you're doing a lot of these exercises, okay? Including your problem set 3. Alright, however, if I am looking for, let's say 7, alright? If the first one, when I reach here, if item equals to X, alright, if I compare, it is not true, alright, okay, sure, I don't return, but I also cannot just immediately return false, right? Wrong, 1, 1, 1, 1. Alright, it's because I haven't checked everything else, I've only checked the first thing, alright, so I checked 1, oh, that's not right. let's continue checking. Let's keep checking until we find it. In fact, there's no else statement. Okay, there's no else statement. You just keep going and going and going and going, and only when at the end you're like, oi, I have reached the last one and there's still no 7 lah. What to do? Okay, no. Return false. Alright, note that this return false is after the entire for loop. Okay, after the entire for loop. Alright, so let's try. I need to save this as exercise 6-2. Alright, and I'm going to run it. Oh, I'm very clever. Never print. Okay, print condition. Okay, so condition is false for 7. Condition is true for 1. Alright, condition is true for 2. Alright, condition is false for potato. Alright, so this is just a few lines of code, right? It's just a few lines of code. I know, again, it's not like the way we humans do it. Like, we will glance through the entire list and see, oh, obviously there's no potato, right? But the computer has to do this sequentially. It can only handle bit by bit by bit by bit of data, right? And the sooner you come to accept that, the better. Haha, the sooner. Haha. Sorry. Okay, where was I? Sorry. Okay, third one. Returns the index of x. Alright, so let's say I should have list still in memory. Alright, so list.index bracket 1 will give me 0. Alright, list.index bracket 2 will give me 1, even though 2 also occurs at index number 6. Alright, if I do list.index 6, it will give me 5. Alright, so it returns the first time it occurs. Alright, and hopefully you have an idea of how to do this. Okay, so here you go. Let me just show you. I'm looking for something. Alright, I'm looking for a number. I start with 0. Alright, for every item, if x is equals to the item, oh, I found it. I just return the number. Again, you see what's going on? Alright. The moment I find the number, I just return it. Alright, after that I can increment it by 1 and let it continue. Another way of writing this, okay, is def index my list comma x for I in range length of my list. Okay, if x equals to my list I, alright, return I. Okay, this will save you from having to increment by yourself because this does incrementing for you. Okay, let's check what is supposed to return if it doesn't exist. Alright, so in this case, I'm just going to not let it return anything. Alright, not let it return anything. Okay, so let me run this just to see. Alright, this one says print. Alright, this one uses the actual one and uses my version. Alright, what happens if I look for something that's not there? Let's say 8. Alright, in this case, this one will give an error. Ours will return none. Alright, it's remember a built-in value called none. Alright, when it reaches this point, when it does nothing, it hasn't hit a return statement, it will just return none. Alright, this is the same. You can leave it there, you can don't. Alright, so what happens is that after it runs through the for loop, it's checked through every single item. It couldn't find an 8. You know, it yells at you for being a complete idiot, and then it says, forget it, return none. Alright, okay. A bit slow for this one. Let's go to reverse list. Okay, reverse list. All right, is you actually want to start counting from the back. All right, and create a new list. Okay, so let me show you. All right, so I give it 1, 2, 3, 4, 10, and it gives me 10, 4, 3, 2, 1. The way you reverse is you start counting from the back. All right, ARR -1 will give you the last item. So essentially, what you want for this new list is you want a new list that goes like this: ARR -1. ARR -2. Alright. Stop playing the ball, are you? ARR -3. ARR -4. And ARR -5. Right. So I've gone and manually reversed this list. Okay. So you can see a pattern here, right? The first time round when you loop, you want to put in -1. Second time round, you want to put in -2. And you want to stop at -5 because after that, there is no ARR of -6. Right, index out of bounds. Right, your favorite friend, index out of bounds. So what I'm doing, I start by creating an empty list. Right, again the accumulator pattern. You'll be seeing this all over the place. Right, then for I in range 1. So in this case, I actually start counting from 1, and I go all the way to the length plus 1. Right, the length starts at 1. All right, and goes all the way to 6. Remember, for range 1, 6. Right. Range 1, 6 gives you 0 to 5. Okay, this is fairly useless. Thanks. Print range 1, 6. Thanks. Well, that's pretty useless, but never mind. range 1, comma 6 will loop through from 0 to 5. For I in range 1, 6, print I. For I in range 1, 6, print bracket I. Alright, so yeah, 1, 2, 3, 4, 5. Okay, then I will just tag on the next item into my list. So this is how you append a list. Okay, append to a list. You tag on this thing, right, with negative I. Then when you're done, right, so not in the for loop, not in the for loop. Outside of the for loop, you return new list. Okay, last one. Sort. Alright, sort I won't go through too much, right? But in essentially sorting, there's a certain algorithm. Alright, these are things that you will probably learn later on in CEP. Alright, there's once you master the languages, then you master all these algorithms. Alright, so what happens is you want to sort from the smallest to biggest. Alright, so what I do in this case is a whole bunch of stuff which I pretty much just grab from the Wikipedia page. Alright, so never mind. So what I do is, I loop through it. Alright, I find the minimum. Alright, and then I compare, I bubble down the list. Okay, so let's say I have this list. So I set my minimum to be the first one. Alright, I go through the list. If I find something smaller, then I swap the two. Then I repeat. Okay, this one I'm not super concerned if you can't get it. Alright, anyway, the algorithm is all there. See if you understand it. Don't worry about if you cannot. Alright. Stupid cat. Alright, next. Write a function. How long do I have? Oh my god, 15 minutes. Write a function, mod list. Okay, so this one is a vector dot product. Alright, so you take this 1, 1, dot 1, 1, you get 1 times 1 plus 1 times 1. This is 1 times 1 plus 2 times 4, blah, blah, blah. Okay, so I will just open this up. 6-2. Alright. So mod list, A list, B list. So first thing I do is, I do a quick check. Alright, it's always good to do a quick check in case your user gives you stupid input. Your user sometimes being the examiner, alright, being us. Alright, so we will give you stupid test cases that will make your program crash and then we will deduct marks and go ha 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 ha. Alright, so don't let us go ha 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 ha. So if the length of A list is not equal to the length of B list, blah, or type is not the same, or or even it's not even a list. Alright, I'm gonna return none. Alright, these are some sanity checks. Okay, so first one says they're the same length. Second one says they're the same type. Third one checks the type of the first list against a type of an array. Alright, how come I don't need to check the type of the second list? Alright, because I've already done it here. Alright, if they're the same type, then this one, if this is the correct type, then so must this. Okay. Alright, then after that, it's very simple. You just accumulate the pattern again. Use the accumulator pattern again. Total equals to 0. You loop through each of the lists, and then you take total, you add it to A list, the item at A list, and multiply by the item at B list. Okay, so run. Alright, 2, 9, 12. Alright, 2, 9, 12. Okay, this is the sieve of Eratosthenes and number 4. Okay, you know what? I'm going to stop this and continue in a separate video. And kick the cat out of the room. Cat.